let's just go over just a suggestion for a wiring harness that should feed our motors and our electronics and sensors reliably. Before we get started, I have to give a warning about LiPo batteries. They are potentially dangerous. They are potentially a fire hazard. The reasons are that they are prone to over discharge or low voltage problems. If you run them down too much, they can be ruined, and then either from that or from an accidental over discharge, they can be dangerous to charge again and they could catch fire. So we want to put in some precautions into our circuit for LiPo batteries. One is the over discharge protection. In my case, I'm using this Sabertooth motor driver. It's a bit of overkill, but it has a LiPo battery protection circuit in it that will shut down any power to the motors if the battery's voltage is too low, to the point where to protect it from being damaged. And I figure if the robot won't work and this thing won't come on, that's a pretty good sign that I need to change my batteries and not just leave it connected and have it run down for some other reason. I'm satisfied with that. You may want to put some other component in your wiring harness that will independently protect against low voltage for the entire circuit. Now, that's another reason why I've made my wiring harness almost completely modular, meaning that different pieces can be connected differently or in pieces. You could substitute part of this quickly with a different configuration because I've put everything in between connectors. So let's start at the beginning. I'm going to try using these batteries, and they came with a it's called an XT60 connector. It doesn't matter what connectors you use. I just bought some of these and used them because this battery came with that. My other robots use a different type of banana connector, but you can use whatever you want as long as it has a certain gauge to handle whatever amps that we're going to be drawing here. So here's the battery. The battery connects to this module, which is my illuminated rocker switch and a fuse. Now, the fuse, this is important, another protection because of the battery we're using. You want some protection against a sudden over discharge, like for example, if there were a short circuit. So I have here a 10 amp fuse in this fuse holder, and this fuse is between the battery and anything else. There is nothing else in here that is in front of the fuse. So why did I do that? Well, let's say, for example, this switch got damaged, or let's say it got wet or something like that, and a short circuit happened in the fuse, in the switch, then the fuse would burn and it would shut everything down, and it would be very easy to replace it. I'm not sure what amperage overall we're going to require, but I'm fairly certain it's less than 10 amps. And that any surge of current more than 10 amps to burn the fuse would probably be because of a short circuit someplace. And we don't want this battery to discharge at such a high rate of current. I have this illuminated rocker switch here. Obviously the illumination means that it's on and it's feeding power through the fuse to these two connectors. What are these two connectors for? Over here we have two buck converters. These converters take a high voltage up to something like 38 or 40 volts, and they drop it down to an adjustable. Using this screw you can adjust it. In this case I have this one set for 10 volts and I have this one set for 5 volts. The 10 volts is going to feed our motors and possibly the Arduino, not necessarily. And the 5 volt circuit is going to be for our sensors and other electronics, maybe the Arduino. We'll see. So I split this so that we could connect both in parallel. And I did that rather than daisy chain those buck converters. I did them in parallel because each of these has a maximum output of 3 amps. If we had them in series, and let's say the motors were to surge, there was a surge of current drawn by the motors, maybe they get stuck or something like, or accelerating very fast or something, it might cause a reduction. The limit here is 3 amps. So if the motors suddenly draw 3.8 amps or something like that, then it might cause this to be short on current and our logic circuits might misbehave. So I wired these in parallel so that they're each drawing from the battery, which is a totally different level of output current. So let's take a look at our voltages here. So on this one, I'm expecting 10 volts. Yep. Okay, so that's within 2%. And on this one, I'm expecting 5 volts. Yeah, that's not a good connection there. Hang on. There we are, 5.05. All right, so that's within 5%, and that's totally fine. So there we have it. We have a battery that's protected by a fuse, and every other component is in front of the fuse. And we have the illuminated rocker. Then we have modules for power here. 10 volt circuit, 5 volt circuit, each of them able to provide 3 amps of current. And this 10 volt circuit is going to connect to my motor driver here. Okay, in order to have some heavy pins, these things would not fit this wire in there in the block here. So what I did was I took some horseshoe connectors and I soldered them on and I cut them in half to create these. But I'm going to turn this off because there's a short danger here. If these were to short out while the circuit was on, it could burn my fuse. And I don't want to do that right now. So there we have our wiring harness. Just a suggestion, you may do it differently if you choose. Good luck.